Hey everybody, thanks for taking time and joining AI Tinkerers. I'm Abhi. Held multiple engineering roles in the past, and currently I head the Developer Advocacy team at DigitalOcean. We're a cloud infrastructure provider. And ever since like the early this year, I come from an infrastructure background, and I wanted to approach AI from an infrastructure standpoint. And the question that I wanted to keep asking was, how would these agents talk to one another at scale? What would that architecture look like? And in order to do that, I had to formalize my thought into a question. And I took some inspiration from history with, it's just a giant canvas, so bear in mind. You had the monoliths, and then the microservice architecture came into existence, and the whole birth of event-driven architecture, building distributed systems came. And I'm like, okay, why can't we take that and apply to AI systems? What would that look like? Maybe operating system is kind of like a bloated term here, but the underlining thing is, what is the plumbing that holds all this together? And in order to do that, I needed a platform or a simulation or an app that I can scale and validate this hypothesis. And this demo is going to be the journey I've made so far in trying to address this question. So I'm going to go over like a high-level business event flow of what a ride-sharing app would look like. Let me zoom out a bit so everybody can see it. Right. So it's pretty simple. You need riders who are requesting a ride, right? And then there needs to be some sort of an orchestrator or a monitor that understands where the user is requesting from, what are the available taxis nearby, is it in a nearby location, they are free, or they are finishing a delivery. And then it needs to send it across to a dispatcher or a center where, okay, if it's in Amsterdam Zuid, someone nearby gets that. And all these are like different types of events that are being generated, right? So this is like a high-level business event flow. And then there's like a billing agent that can operate asynchronously, because the moment it gets the information from where the user needs to be picked up and dropped off and the current city information, it can do the calculation asynchronously and just put it back. Store it in a database, send it across as a notification for the user, right? And now I would like you all to just imagine, I'm going to show you the system design of how I built this. It's a simple POC, right? Imagine you're sitting on top of a tall building in Amsterdam and looking down on the city, and you see multiple users requesting a ride, and you have a couple of taxis roaming around. So you as the orchestrator, so if you imagine yourself that way and approach this following diagram that I'm going to show you, it might be a little more clearer. So what would first an anatomy of a ride look like, right? You need to first, I'll zoom in. You need to know the user ID, you need to know where the location is, drop-off location, and the city. And then at the same time, when this information gets passed on to the monitoring service here, it basically understands which taxis are available and rest says that Jan is available now and assigns Jan to this particular user and gets the live coordinates from Jan, right? What's the waiting time and how long? And all this information is just propagated throughout the architecture. The reason why I'm showing you this is because then when I see the show you the live demo, you'll be able to visualize it better. And then you have the RoboTaxi, which is Jan here, and it's constantly sending, hey, I'm here, I'm about to pick up, I'm occupied right now, so that the monitor understands that, okay, you can't reassign someone who's already been occupied, right? At the same time, you have the billing agent who knows that it's in Amsterdam, gets the distance, tries to calculate what's the current rate here, cost per kilometer, and applies that and stores it. This is happening in sequence. I'm showing you in sequence, but this is a distributed system. This can happen asynchronously at any time, right? So this is how the system design is going to look like for the app. So here are the couple of services, right? That's me just requesting. Here you have a reverse proxy and a fast API backend, which has the booking agent. Basically, you can say, hey, I'm here, pick me up. And then what it eventually does is tries to figure out, does some reverse coding. So I'm basically using external services like Mapbox to get the actual routes. And these routes that you're going to see in the simulation, they are actual routes of the city and not just like fake points that are being plotted. First determines the location, does some data synthesis, cleaning there, and then publishes to Apache Kafka. I don't know if you all worked with Apache Kafka, but I would give an analogy here. Imagine it's like a newspaper, and then you have multiple sections. You have the sports section, you have politics, you have various sections, and each one is probably interested in just understanding, like, I just want to read the sports section, right? Similarly, you have the concept of like producers and consumers. A producer will just basically produce certain messages to a particular topic or a section analogy. And then there's a consumer that will read this information and then say, okay, what will I do with this? So imagine these services right now, and so for example, the ride orchestrator is completely unaware that there is a taxi simulator. All it knows that I need to process a ride request, I need to understand the taxi updates, and do some algorithm myself and apply the ride to the particular user, right? And once this information is there, I'm just spinning up a billing agent here that understands, okay, this is in Amsterdam, performs the calculation, stores it in a Postgres, or first saves it in a Redis cache so that I can just keep looking at it. This is like a high-level system design, right? Let's try to spin it up in action. So I have a shell script that's basically sets up some environment variables and all that, and then I have a compose file with all these services. And it's going to spin up everything one by one. So these are actually the backend tech stack. I'm using Docker, and obviously I'm from DigitalOcean, so I use like managed DO stuff. But this is happening locally right now. But this has also been deployed in production. And I use Apache Kafka and NeonDB for serverless Postgres. So it's spinning up the Kafka broker right now, setting up the topics, and this is happening live, by the way, and you can see that the broker is up, the backend service is coming up right now. Right, so I've made a lot of money in the last couple of days, I think. These are like the history of rides that's been happening. It's just pulled from the database. So everything is up and running, right? And you can see that these services here, like you have the billing service up, the backend is up, the front end is up. So it's now the moment of truth. Let's go here. So we're right now here in Amsterdam. And you can see here that no rides are there. So now I'm going to simulate a ride. Like I'm going to spin up multiple taxis and multiple requests. So let's do that. Let's go back here. I have another, like a job that basically says, here are the number of rides. So let's say we'll do 20 rides. We'll do location, Amsterdam. And maybe if it's not clear, I'll just clear the screen and write it here. We'll do 20 rides. We'll do location, Amsterdam. Oops. And I'm going to say generator start. So what this basically does is simulates like 20 different requests from random people in Amsterdam. And then we're going to see how random taxis are going to go and pick them up. And these are actual routes that'll be driven. Right. So you see so these are actual users now, I mean simulated users obviously, but these are actual routes it's actually driving in and it's going to pick the user up, drop the user off in a particular location, and this is happening right now. And you can keep like a tab of all this. So what this now truly helps me is I have a system that now I can scale and deploy across the globe. Like I can simulate hundreds and thousands of such requests, and I have the data for it. And now I can double down and analyze and apply more intelligent services and build more intelligent agents, and then try to validate my initial hypothesis that EDA or event-driven architecture will be powering multi-agent communication in the future. And that's the demo. Thank you. If you have any questions, happy to chat. Also, you can connect and happy to chat. And this is a side project, by the way. It has nothing to do with my company.
Thank you for a good talk.
Yeah, you're recording.
Yeah. Not from the first question, but
no worries,
recording.
No worries.
Questions?
I can project my voice, it's fine. So I just want to ask, what's the point of...
I would recommend
enough?
Yeah.
All right, so I just wanted to ask, like, what's the point of orchestrating this with agents? Like, I know it's a side project, but what benefit would it give over traditional orchestration methods?
No, so I'll take a step back. The question that I wanted to answer is, how will they talk to one another at scale? And my question that I want to answer is, by building such a thing, and now replacing these services with more intelligent services, and then everything is powered by Apache Kafka in the middle, which is like this whole bunch of message queues that is happening. And I want to validate my hypothesis, and that's the journey that I've taken to, I just want to answer this question. I'm not there yet, but I have something right now where I can double down on this.
Okay, that's clear. Thank you.
Yep.
Yeah, thank you very much. With event-driven architecture, you have the replay function. Like, have you played around with like changing something in your? Oh, sorry, is better? Yeah. So, like, did you ever try changing the communication protocol or strategy and then replaying a simulation to see what changed?
No, I've not done that yet. No. And I know that you recommended it last time when you met the s2.dev, and I wanted to play around with that. I've not done that yet, but I did. I am going to speak to them to see how to integrate that.
Any more questions? That's it.
Thank you very much.
Thank you.